Okay, so in today's lecture, the lecture 4, we are going to study something that is really the most important thing of the probability theory, which we call the conditional probability. Now, in conditional probability, we actually look for the relatedness of one event with another event, that whether if we are interested in finding the probability, calculating the probability for some certain event, whether we find any other event that is related to that particular event, if we come to know that another event happened which may boost up the chances of our required or our desired event, then we calculate the probability of our desired event in a different way, so that we get the some better results or some updated information or some updated probability of that. So let us start it with some example. Say for example, if I am sort of rolling a die, so I know the outcomes of the die, that either I would get 1, 2, 3 or 4, 5, 6. Now if my desired event is that I want to know that what are the chances that I would get 2 once I am rolling the die, so I can see that the probability of getting 2 is 1/6, that is some 16.7%, that the die would roll a 2 when I am rolling it. So but if someone tells me that what are the chances that you would get 2, given that you already know that the die has rolled an even number, while I was rolling a die and I was interested in finding the probability for an outcome that is 2, if someone told me that okay, now tell me that what are the chances of getting 2, when I'm telling you one more thing, that the die has laid an even number on its face, so now I would not see the probability of getting 2 throughout all the 6 outcomes. Why? Because someone provided me an extra information. Now my sample space, which earlier was 1, 2, 3, 4, 5, 6, would get shrunk to simply 2, 4 or 6. Like someone told me that the die has already laid an even number on its face, so now I just only need to find my 2 in these even numbers, not in all the possible options. So if I calculate the probability of getting 2 now, I am provided with one condition, and that condition is what? That what is the probability of getting 2 when you know that the die has laid an even output. I am looking for getting 2 while I have information that the die has laid an even number already. So this probability now would be something 1/3, which is maybe some 33.3% probability that I would get a 2 when I roll the die. So this thing is called the conditional probability, and here we say that the probability of 2 condition on the fact that the die has laid an even output. Similarly, if I am talking about the probability of birth month of some person, say for example I say that what is the probability that Ali has got birth in the month of January, so definitely his probability of getting birth in January is 1/12. But if someone tells me that okay, I can give you an additional information that the month in which Ali got birth starts with J, So once I got that information that okay, Ali has got birth in a month that already starts with J, now I don't need to search his birth month among all the 12 months. I would only look for it in the months January, June and July. That would become the probability of his birth being in January, provided the fact that the month starts with J, would become 1/3. So in this situation, in this case, we say that when we are looking for a certain event, for the event of interest, if someone provides us some additional information, if that additional information works for us, if that additional information becomes useful for us, and it gives us or updates our previous evidence, our previous belief, it shrinks, it makes smaller our sample space, so that additional information updates our probability. It improves our chance of getting that desired output, that desired event. So that probability is the conditional probability of that output, it is the conditional probability of that event, and it is the probability of that event conditioned on the provided information, on that provided condition which already has occurred, making sure that that condition or that information is related to that event, it is related to that outcome, it is not unrelated information. Say for example, if I ask that what are the chances of getting 2 on the face of die, when I tell you that it was raining outside, so raining outside would not improve the chances of getting 2 on the face of die. If I tell you that what are the chances that Ali has got birth in January, provided that Ali likes chicken, so whether Ali likes chicken or not, that would never improve the chances of guessing that which month actually Ali got birth in. So when related information is available and that information updates our present information, our sample space, our evidence, and improves the chance of the probability, we call it the conditional probability for that certain output or that certain event. So now we would write the relation, that how to calculate the conditional probability once we know certain condition. Let us see. We say that the probability of A given B is so this is the actual relation. This is the actual relation that we use while we calculate the probability of certain outcome A, given the fact that some other event B has already occurred. The probability for a certain event A to happen when we know that some event B which is related to A already has occurred. Now let us make sense of this part, that what does this mean. As we discussed in the example just a moment ago, that once we have the condition, our sample space becomes smaller. So for example, this is my complete sample space which contains all the possible outcomes, all the possibilities for my event. But when someone provided me the condition that okay, your B event has already occurred, now whatever I have to find A, I am going to find A inside event B instead of finding it in the complete sample space. So someone told me that your event B has already occurred. Like in the case of die, when my sample space complete was 1, 2, 3, 4, 5 or 6 dots. This was my complete sample space. So I was finding 2 in this whole sample space, and its probability was 1/6 because it is 1 out of all the 6 outputs. But when someone told me that I'm giving you an additional information that the die has led an even output. So once I'm told this fact, once I know this thing that the die has led an even number, it is useless to search in the odd outputs. So now my new sample space would become this one, which contains only the even outputs, that is 2, 4 or 6. So I would look for 2 inside 2, 4 and 6. So when we were talking about the relative frequency approach of the probability, so there we said that we take the number of elements in A and divide them with the number of elements in the sample space, so that becomes the relative probability for A. Relative frequency of A and becomes the probability of A. So now if we are searching for anything, we are finding the probability of anything, say for example 2, we would take the number of outputs that the 2 occurred, that is 1 times, and we would not divide them with the number of elements in the sample space, but we would take the number of elements in set B instead of sample space, because our new sample space has become smaller, has shrunk to the sample space which is set B. So we would in denominator take the probability of set B, the new sample space that we have got. In numerator we would find A inside B, like we would see that if my A is getting number 2 on the face of die, so I would search 2 inside the event B. So I would see that how much part of my event A overlaps, intersects, is found inside the event B. Once I found that how much part of A is present inside B, I would take its probability and divide that whole probability with the probability of my new sample space, which is the set B. So we say that once we are provided that some other event B has occurred, now our sample space would become this set B. If this is my proposed event, this is the event in which I am interested, say for example this is event A, and I want to see that what are the chances of occurrence of A. What are the chances of occurrence of A given that B has already occurred? So B has already taken place, it has occurred already. I would see the chances of A being present inside B. I would see the chances of A being present inside B and divide those all chances with the chances of B to occur, because my new sample space is B. So this would become the conditional probability of getting an event A when we know the condition that B event has already occurred. Okay, so let us do the same rolling die case once again, that whether we really get 1/3 of the chances when we are conditioning it on the condition that the die has led an even output. So here we are saying that the probability of getting 2, given the fact that the die has rolled an even output. So their chances must be the probability of getting 2 and an even number divided by the probability of getting an even number on the face of die. So once we have the sample space, if we see that how many chances do we have to get a 2, and that 2 must be an even as well, like how many chances are there that the output is 2 as well as an even number at the same time. So there is only one possibility out of 6 which satisfies this condition that it is 2 as well as an even output at the same time. So the probability of getting 2 and an even output at the same time is 1/6, while the probability of getting an even output once you are rolling the die is, if you got 2, you are done with it because 2 is an even, 4 is an even number, 6 is an even number. So the probability of getting an even number once you are rolling a die is 3/6. And if we simplify this, this would surely become 1/3, which we already saw that if we are looking for 2 inside the even outputs only, like inside 2, 4 and 6, a set that contains just even outputs, that would again turn out to be 1/3 because it is one of the 3 numbers those are possible for the even outputs. So this is all for the conditional probability.